Okay, so this is 3. What am I saying? 2. I wish it was 3.3. Still have long ways to go. But anyways, this is 2.3. And there's a lot of question on this section. Kramer's rule and other fascinating stuff. So let's get right into it. Okay. So first 4 questions I believe is basically we have this condition. The determinant of constant A equals to constant to the power of n, where n is the size of the matrix, right? So this would only work for square matrices, right? 2 by 2, 3 by 3. Because if it's like 3 by 2 or and so on, right? This would fail. So, but fortunately, all the matrices that we are dealing with for this section is all square. So, but you know, hypothetically, I could do this and then give you like a non-square matrix, right? And then say solve this. Your answer should be no, we can't solve it, right? So that's what you're supposed to say. But anyways, I really am getting tangent now. This maybe it's because I'm getting tired. Okay. Anyways, moving forward. So let's go to question 1 and see if we can satisfy these conditions. I think there's a really easy way of doing this after doing question 3, but let's just pull through. So 1, right? So I just first question is a matrix is this, and I haven't had a chance to write it down, but k equals to 2 for this particular case. So right. So all you have to do is just sub it in, right? So here, you know, a times 2. Remember, if you're timesing 2 to a, then you have to times all entries, right? Like timesing vector, right? So it's going to be that, and then this will be just 2 to the power of 2, right? Because the matrix size is 2 by 2. So 2 to the power of 2 is going to be 4, and the determinant of just a regular matrix, solve it in, and then you get the right answer. There's a better way, I think, but please, because of my current work and the other schedules, I simply can't attend to Maria's tutorial. I go to Ganesh. I finally remember his name now. I used to call him the Indian guy, Ganesh, right? So yeah, I go to his tutorial. So I wish I could ask this, but I'm wondering if my cheat key would work. So it's not really cheat key. It's pretty simple once you see it. But anyways, moving on to number 3. I'll show you what I mean, right? So similar deal, right? We have a 3 by 3 matrix. K is -2, right? So this is where my solution gets tangent from the book solution, right? Determinant -2a. Yeah, we got that. Here the n is 3, right? Because it's 3 by 3. So you know, make sure, right? And so forth. So I did all this, right? But I was thinking, okay, remember the theorem we were talking about in 2.2? Remember number 1 basically says if you take the k out of a single row, right? Then it's gonna be k times the determinant, right? I was thinking, why don't I just do that 3 times, right? So take 2 out, -2 out of the first row, it will be -2 times the whatever. So I'm gonna take -2 here, -2 here, and -2 here. So -2, -2, -2. What does this look like? Look like this guy, right? So I think it, like I checked it over, but I'm pretty sure that is it, right? And if that's the case, then if you take the -2 out, -2 out, -2 out, remember, -2a is basically ka, like sorry, -2a here, right? Times the first row, second row, and third row, right? And technically it just times all the entries, but that's the same thing as saying -2 times the first row, second row, third row, right? But if that's the case, then isn't this essentially same as this? So, because here they're not asking what the determinant is, they're just asking if these are true. Well, in front it's -2 to the power of 3, which is going to be, what the hell? -8, right? So, yeah, so we have the exact same number in front, we have the same matrix, so their determinants have to be the same. I mean, we don't have to calculate it, right? So, I'm hoping that one of you will ask. I would send an email. I might ask Digby. I don't know if I can get hold of Maria on Monday. Monday is a really busy day for me. So, but anyways, So this might work, I think. It should work. But, worst case scenario, I mean, we can go through the good old-fashioned elimination process to get there, right? So, I could do it right now, if I have to. But, so for people who are not quite nervous about this, because, Maria doesn't like smart ass, right? So, actually, no, that's not true. I really speak horribly of her, but, she's like a mathematician, right? She's very precise, so, just, we can't really quite keep up to her standard, unfortunately. But, that's our problem, not hers, right? What she says isn't wrong, so. Anyway, I really need to stop talking. Okay, so what we're going to do is I'm going to do -4 to -6. So I'm just going to find the regular determinant, okay? So if I were to do that, then I don't really want to do it. That's stupid. $100, Austin would hate this method after he sees this. I'm not sure if he watches my video, but whatever. So it's gonna be, I don't want to do it though. So we can make this 0, 0, -2, 8, 10. So 2 times, so this times, yeah. So this is how Maria showed us to do it. So I like that because I can keep on track of things because I'm a visual learner. So -2 times -2 is going to be 4. That will cancel out. -16. Oh no, 16. 18. -20. -26. That's going to be 3 to get rid of that. So that would be 0. Ooh, number gets really big. 24, 20, and that's going to be -30, -32. Ooh, I do not like that. I may need the whole thing. This might get ugly. Yeah. So, make sure you can always rewind your video to get there. But anywho, so I'm gonna put, so that's 0, 0, 0. So it's gonna be 0 plus. Do I need to do this anymore? So it's gonna be -2. Sign chart, right? Positive, negative, positive. So that's gonna be +1. That's gonna be 18, -26, 20, -32. This is what happens when you drink caffeine when you're really late. It starts to have an effect on you. But anyways, 2. That's gonna be, oh god. Okay. This -26, 20. Yeah, it's gonna be what is this gonna be? It's gonna be a huge number. So I'm just gonna type it in. -32 times 18 plus 40. Oh, why are you doing this to me? Plus 40. No, it's not 40. It's 400. $352. $352. Okay. And that's A, right? That's only A, right? So that's the determinant of A. So if it's 2A, it's gonna be, let's see here. Okay, so yeah, I was having some difficulty with basic algebra, but I managed to get it. So I know that your textbook uses the determinant A to find the determinant straight on the get-go. I think that's unwise. I mean, even after simplification, I still was having trouble getting the right answer. So nonetheless, so this is what I did. So please use these. Do not do what the solution book is doing. Because literally you're just doing -4 times determinant of this. That's just a lot of calculation. Just do a simple elimination on the get-go, and then we can ignore all this, and all we have to do is -2 and the determinant of that, right? So just follow through, and this is how you get it. And the other one's the exact same thing, but it would be so much easier because we're just deriving the determinant of A, right? So, okay, so, anyways, so if that's the case, so, 2, -1, 3, 3, 2, 1, 1, 4, 5, right? So determinant of that is going to be 0, 0, 1. Hopefully I don't screw up this time. 4, 5, -2, negative 8, -9, -2, -10, -10, -10, 7, right? Okay, and this is -3, so that's going to be -3, -12, -10, -15, -14. Okay, so let's see here. That's gonna be okay, so that's gonna be 1 times 1. For a sine chart, for sine, remember the sine chart, the plus minus plus, right? So, and then that's gonna be -9, -7. Please come up with the right answer, please, please, please. That's gonna be okay, -9 times -14 positive, minus 7 times -10. Okay, so that's gonna be -9 times -14, minus 70. It's gonna be 56. Now it says 2 to the power of 3 negative times determinant of A, right? So if that's 56, please give me the right answer. Let's see. Oh, beautiful. 448, because that goes in there. Good. Okay. Oh, sorry. Minus. Got excited there. Okay, but anyway, so this is how you would technically solve it if my shortcut is not acceptable to your professor. But I encourage you to ask, because I'd rather do my method than going through this hassle. So, on to the next question. Alright, so we should be pretty comfortable with the elimination process. But anyways, I'm just doing this because this is a far better answer. I keep repeating myself. I think I'm going crazy. But anyways, so that's what I would do for number 4. But if you must insist on determinants, then actually this one won't be too bad because there's 2 zeros already, so I can live with that. Okay, so if that's the case, then that's going to be no, wait, I did erase that one. 3, 3, 9, 0, 6, 9, 0, 3, negative 6. Yeah, equals 2, 27, 1, 1, 3, 0, 2, 3, 0, 1, negative 2. Okay, so 2 zeros, beautiful. So that's going to be 3, 6, 9, 3, negative 6 equals to 27. And then, it's going to be 1, 2, 3, 1, 2. Keep forgetting the sign chart. Okay, but it's 1, right? That's the whole point here. So that's not minus, by the way, so that's that. And that should give me the same answer, 3, negative 36 minus 27. I'm just going ahead. 27, negative 4 minus 3. And this should give me the same answer. Let's hope it does. Negative 36 minus 27 times 3. That, yeah, okay, as you can still see, that's going to be negative 189. Uh-oh. Back up. Okay, I panicked. It's I thought this will become -1 or something, but now it's not because of the sign. Okay, so choose your poison. Either way, it works, as far as I'm concerned. All right, moving on to number 5. Okay, on to number 5. So this is what I have so far. So we have these two equations. We have to see if del AB and BA are equal, and if del AB equals to del A and del B. So maybe I should rewrite that. So the question is del BA, does it equal to del AB? Should have wrote the question earlier. But yeah, actually no, there's a space right there. Okay, so yeah, so delt AB or delt BA and delt A plus B equals to delt A plus delt B. I don't know if Maria had a chance to talk about this, but there is a specific, because technically speaking, this should not be equal. This is not a general equation. But there is a mention in the textbook saying that in certain occasions this is true, and it's useful to know that pattern. So, but I'll talk about that a little later. But anyways, or I might actually, well, we'll see. I might talk about it or I might not. I'll see if I need to or not. But not very important. The point is this don't equal. But we're gonna find out. So I'm gonna do del AB. So it seems really weird how fast I did it, but like I just didn't want to show the work simply because like you're just multiplying the matrices, right? So it's gonna be rho. So I'll show you how I got some of the numbers, right? So here and there, right? So it's gonna be 2 times 1, 1 times 7, 0, whatever. So 2, 7 is 9, right? Let's choose this number, right? For example, right? So how are we gonna get this number? It's going to be third row and second column, right? Third row and second column because it's in third row and it's in second column, right? So 0, 0, 0. So 0 is going to take out all this, right? 0 times -1, 0. 0 times 1 is 0. 2 times 0 is going to be 0. So that's why it's 0, right? So remember, when you times these 3 entries, like this one, this one, this one, this one, this one, this one, for example, right? Make sure you add, right? Not multiply. But we've done this in earlier sections, so this should be pretty straightforward. If not, go back and review. But nonetheless, this is what I have. So determinant of A and B, I get -170. If I do del BA, I also get -170. So therefore, this 2 will equal. Now, we're going to del AB, so what I did was I just got the A. So addition is a little different from multiplication, right? So if it's A plus B, then I'm going to do first entry, add by positions, right? 2, 1, 3, 1, -1, 0, 0, 3, 3. You're literally adding them, right? So, I can erase this now. Okay. So now, see, I have this now, right? So I'm gonna see if I can calculate it individually and see if they add, right? Because we have to be able to prove from left and right side, right? So del A is gonna be, oh no, it's gonna be, we're gonna use this one right on the get-go, right? So that's gonna be 2. Is that positive or negative? Positive, negative, positive. Yeah, positive. That's going to be 2, 1, 3, 4. Oh, that's nice. So that's going to be 2 times 8 minus 3, 5, 10. Del A, del B is going to be, oh yeah, I could have done that. I should have done that. Oh well. So I'll just do that right now. 5, 0, 1, 7, 1, 2. Just need to get rid of this guy so that I have 2 zeros. So that's going to be just adding 8 and 5. It's going to be, so I'm going to use this 2. I'm going to use this part. what am I doing? 1 times, not positive, negative, positive, yeah, positive, and 8, 5, 5, 1, 8 minus 25, negative 17, 10 and negative 17. So that's now. Just so that I have room. So if that's the case, let's see if that's true. Equals del A plus del B. Negative 30 equals 2. 10 plus negative 17. Does it? No. So it does not equal, right? So that's all I wanted to. That's basically what the question is on about. We're gonna try number 6. Okay, so this is gonna be number 6. So just to so therefore, dBA equals to del AB. So that's what I have. I'm gonna prove the other part now. Okay, and this is the so this wraps up question 6. Take a look. We didn't do anything differently. I just did exactly the same thing as we done in number 5. So check it over. If you got it wrong, this is pretty sure I'm 100% confident this is right. So just try again if you don't get the right solution, or come after me if you got it right and I got it wrong. Either way, this is how I solved it. Let's move on to the next question, 7. Oh, I lied. I'm not gonna do question 7. I realize that you guys all have solution manuals. How you got them is, be discreet about where you got your things, right? So, anywho, so I'm gonna try just a few of the even question. Again, this is nothing groundbreaking. All we're doing here is to check whether matrices can be invertible. So, and the only rule you need to remember is that and we should know this from our earlier section, inverse A exists and if and only if its determinant does not equal to 0. Okay, so that's why. So if we look at number 8, don't even have to do any elimination simply because there's 2 zeros, so I can just start. So that's going to be 3, 1. Just to clarify, so that's plus, minus, plus. So plus. So that's going to be 2, 3. Blah, blah, blah. You have 42. So it does exist. Because it's not 0. Number 14. I thought I'd do it because at first I was like, oh no, square roots again. This is going to be algebraic nightmare. But what I did realize, hey, third column is all zeros. So I'm going to choose this one. So 0 times 0 times 0 is going to be 0, right? Oh, sorry, not 0 times 0 times 0. What am I doing? 0 times anything is 0, 0 times anything is 0, 0 times anything is 0, so 0 plus 0 plus 0 equals to 0. And if it equals to 0, can't be inverted, right? So in this case, inverse of A does not exist. So I'll let you, I wouldn't really bother doing this section necessarily, unless you're having trouble finding determinants. If you're still struggling, oh, I'm making these mistakes here and there and so forth, then please do them. But you're not going to really learn anything new from here. So, manage your time wisely. Anywho, we are going to go to the next section, question 15. Okay, so this is question 15. So again, nothing too difficult. Basically, you're doing the similar questions as what you've been doing earlier, just trying to determine whether the matrix is invertible or not. In this case, though, you have some unknown variables, so a little annoying, but again, it's the same idea, though, right? So if we want to determine whether it is going to be invertible or not, like we've done before, we try to find the determinant, and it better not equal to 0. So how do we do that? So we just find the, same, it's 2 by 2, so easy, right? This times this minus this times that. So I have that. So if that equals 0, then, it's not invertible. So this is going to become quadratic equation. Every time when you see quadratic equation, actually it's a pretty sad story. My math teacher used to play a quadratic formula song, on as a background music every time when we went to class. So for me, this is something I could say, if someone were to wake me up and it's like, what's the quadratic formula, right? I'll start singing like I'm a broken child, right? But for some of you that may not be the case. So I really encourage you to memorize this. Drill it in your head. I don't know how you're gonna make it happen. But try to memorize. It's not too bad, right? So the equation you'll find is x equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, yeah, see how damaged I am? But anyways, I just put k here because we're not using x, we're using k. But it's the same idea, right? So the only thing, if you're rusty with this thing, is that you're gonna come up with, so basically your goal is to come up with a simplified quadratic equation, right? Once you do that, just use this format, right? If it's regular k squared, k and whatever constant is, right? Whatever coefficient goes in front will be your a, whatever coefficient goes in front will be b, and so forth. So sometimes you could get confused because let's say here's negative 5, it's like, well, it's positive b, right? So should it be negative, it should be 5? No, it's negative 5. Whatever is in front of k will be is the b value, and so on, so on, right? So if this was not plus 2, if it was minus 2, c will be minus 2, right? And then, you have this formula, so once you have a and b and c, just plug them all in, and then you're gonna get this magical value, right? So, yeah, so that means when k equals to this or this, oh, by the way, plus or minus just means, literally when I say plus or minus, right? So that means if I have this answer, it's gonna be plus, or it's gonna be same thing minus, right? So that's all it means. So, but when k gets to this values, a determinant will equal to 0, right? So but the question isn't really like what k value do you need to have so that it becomes invertible. The question is asking which values will allow this matrix to be inverted. So anything but this or this, right? So you could say something like del A equals to, whoops. If it equals to 0, then it won't be invertible. Oh no, my pen is dying. Yeah, so it can't equal to 0 or inverse of A exist if k does not equal to this or this. And yeah, and anything, yeah. Then you could, if you want k equals to real values, if you want, you could mention that if you want. Basically, the point is k can't be this or this. Anything else, we can invert it, right? That's all it means. Now, what is this? It's just some really, really horrible irrational number. I wouldn't recommend it, right? I know some of you may have learned this trick from high school using graphic calculator. You could just do a function of this, right? Function of this, graph it, and then look for the x-intercept, which is fine because that's what these are. Here's the problem though, and you probably know this too. The graphic, if you find the x-intercept using graphic calculator, it will give you decimal numbers. This is a rational number, right? So those decimal numbers don't really have a lot of meaning. Your prof is probably looking for this. You probably went over this in Math 30 and so forth. So yeah, so I encourage you to get very familiar with this, But again, it's not rocket science. This is Math 30 or 20 or even. I was homeschooled for a while, so I don't know how the exact flow goes. But this should be something you've learned already. So if this is rusty, just go through them or do some reviews. You should be fine. We're going to the next question now. Okay, so this is question 18. Since I thought you'd be able to do 17 on your own. Check the solution manual, but 18 is right there. Yeah, so the only trick, see, I was worried, it's like, wait, there's like 2 unknowns. Don't like that, right? How am I supposed to do that? And I just thought, okay, wait a minute, these two I can get rid of 1, right? And do I need to use any case? No. So, right? So I was like, oh, okay, then that's the best way to go. So that's what I did. So I did this. I got -1. So I got subtracted the first row with this third row. So -2, 2, 0, -1, so forth, right? So I did that. Maybe I thought, okay, I'm going somewhere. I have 0 and I have 1. I gotta get rid of this. I have to get the k's involved, second row involved. I really don't want to, because every time I subtract or times anything with a k, things get more difficult. But, you know, that's why when I got rid of the first row, I purposely used the third row so that I don't have to touch k. But now I don't have a choice. So I did that, and fortunately it turned out to be not too bad, right? So once I have that, so I have 0, 1, 0, I can totally use this. I'm going to ignore all the zeros, so it's going to be 1, sign chart, plus, minus, plus, so that's going to be plus, and then it's going to be 1, -1, see that? So fortunately this isn't, you know, like k plus something, k minus something, so it's not going to become quadratic equation, which is beautiful. Anywho, so I do that, and so that's that. The rest is just algebra. I find k1, so you know, k cannot equal to 1/4. K is all real numbers. I don't know. For a to exist. Why not, right? That's all there is, right? Just make sure you don't get confused. Like, oh, I found the critical value, so that must be the answer. No, it's anything but this, right? Because determinant cannot equal to 0 if you want a to be invertible. So, anyways, that's that. I think it went long enough, so I'll just make it as part A, and I will be uploading part B soon. Hang in there, guys. Actually, more importantly, John, hang on. Oh god, okay, because we're not gonna have to deal with vectors. Oh, that will be fun. The dot products are amazing. But anyways, okay, I'm not gonna give you spoilers. I will start working on 3.1, and we'll see each other very soon. Oh, okay, what am I talking about? No, not 3.1. I meant... well, I will be doing 3.1. Okay, but we gotta finish at 2.3, so... Anyway, yeah, okay, so... Now that I got my sanity back, I will see you back in part B.